Our next unit is on statistics, chapter 14 in our textbook. Lesson 1, we're going to do this very quickly. We're going to not spend a lot of time on the concepts, terms and concepts and measures of center in this video, because most of this should be reviewed that you've reviewed for how many years, probably since 4th grade. So we're not going to spend a lot of time on sections A and B. What does data tell us? Data can tell us whatever we want it to tell us, because that's the magic of math. We can make the numbers tell us whatever we want. We can give you the data, whatever we need to give you. That's the hard part. So anytime you read statistics in magazines, see it on the newspaper or on the news, don't believe everything you read. Especially statistics, because whoever is telling this statistics is going to want to tell the data that they want you to hear. They're going to give you the information and make it seem like it's whatever you want or they want you to hear about whatever it is. So here we go. So key stats and concepts and terms. I'm not going to go through all of these. You can write them all down. They're all in your book. But population and census is one thing that's really kind of important, especially when we get to standard deviation, a population and a sample. Survey data, singular term is datum, parameter statistics, distributions, and so on. We have a couple different types of distributions: symmetrical, positively skewed, and negatively skewed. Notice we used to call them skewed right and skewed left, but now we'll talk about them appropriately by calling them positively skewed and negatively skewed. So positively skewed is skewed to the left, negatively skewed is skewed to the right. Outliers are data that is much larger. We'll talk about how to determine whether something is an outlier. We're going to talk about some types of statistics.
There are 2 types of statistics.
Categorical and numerical statistics. Categorical is qualitative, like a color. Numerical data is quantitative, like measurements, heights, distances, times. Within numerical, there's 2 types of numerical statistics. There's discrete data, which we can count. I can count how many people run. I can count how many things like that. Or continuous data which is measured data by time and so on. Displaying data. We can display data in several different ways. Here you see a column graph.
Not a bar graph.
A frequency histogram. Notice the difference between them. Column graphs have spaces between the columns, typically used for discrete data, and histograms are used for continuous data. They have bins. The bars are basically what we call bins, and it contains data that, like in this case, goes from 3.3 to 3.5 in this one column. It's all the numbers between 3.3 to 3.5, and then it goes from 3.5 to 3.7 and so on. So each of these bars, columns, have data built into them in bins. Measures of center. A measure of center, X bar is the average, median, middle number, mode is most frequent. We've talked about those before. Distributions. One of the key components of statistics is we need to understand the shapes and how statistics how mean, median, mode affect the shape of a distribution of data. So they can be symmetrical, the mean or median in the middle. So here, the first one, we see the mean and median in the middle. We also have the mean and median in what we call a bimodal set of data. So this mode has a mode. This is mode 1. This is what we call bimodal. It has two modes, but the mean and median are still in the middle. If it's symmetrical, the data is, the mean and median are exactly in the middle. But when we start moving the mode around, or things become skewed one way or the other, positively skewed or negatively skewed, the mean and median move with that. So example, if we have, the average salary of the adults in this building, and then we bring in a person like LeBron James or Kevin Garnett or some of those people that are getting paid millions of dollars, they would be an outlier, but they would skew the data one way or the other, positively or negatively. And the mean, the average would get pulled towards that outlier. So the mean would get pulled towards that outlier because they would raise the average, in other words. So things like that, and so that oftentimes happens with CEOs and things like that. Companies will put out their average salary, and it looks really great. So when they're trying to hire people and it's very competitive and they're hiring people, they'll display the average salary. But that average salary might include the CEOs, the vice presidents, and so on, which is not truly the average, or not truly the average of the position maybe you're applying for. So you got to be careful with a lot of information like that, especially information that's given or trying to sell you on something. They're going to give you the data that they want to give you. All that we have left to do now is we're going to have an assignment in class, but I'm also asking you to complete an investigation, which will also be done. And again, investigations, remember, are worth a single learning target in class.